Okay, good evening everyone. Welcome to the IMAX here at Glasgow Science Centre for tonight's David Elder Lecture, which as always is supported by the University of Strathclyde. They are also supporting us in hosting the Apollo Remastered Exhibition, which some of you have already had a chance to take in. The rest of you will have a chance to enjoy it after the lecture, so we are really grateful for their support. So we're about to get started. I'm going to be handing over to Andy Saunders, who's going to be talking about his incredible book, Apollo Remastered. I will not keep you too long. It's just to let you know a little bit of housekeeping and a little bit of the logistics of tonight. So first off, you will get to hear all about Andy's amazing book, Apollo Remastered. You'll get to take in some of the images on what is Scotland's largest screen. I cannot wait to see your reactions for that. After the lecture, you will have the opportunity to head back onto floor 1 of the Science Mall to explore that exhibition. You'll also be able to head into the planetarium to sit, listen to the audio of Apollo 17 in real time and also watch some of the images there. And we'll also be hosting a book signing in the Space Zone. If you haven't already got a copy of Apollo Remastered, we only have a handful of books available still to sell, so you do need to be quick with that. Andy has said that during the lecture, he's more than happy for people to take some photos. Just be aware that before you get your camera out, just make sure that the flash is switched off and that the screen brightness is dimmed, just so that it doesn't affect anyone else's enjoyment of what's going on the screen. If you need any help during the lecture, please do let one of my colleagues know. We'll all be running around in teal t-shirts and we are more than happy to help. After the lecture, I have no doubt that you will have quite a lot of questions for Andy about the whole process of how he makes these images look so much better than the ones that we're probably used to. Might have questions about the Apollo missions. I'll leave that up to you. If you do have any questions, for those of you in the room, we will be handing around some microphones, so please be ready to talk into those, because it is quite hard to hear people when you're in the IMAX, just due to the acoustics. We are also being joined by people at home, joining us online via YouTube. We have people registered to view from as far away as Hawaii, which is pretty exciting. So if you are joining us online, we're delighted that you're virtually here. And if you do have any questions, please do pop them into the YouTube chat and just make sure you put question in capital letters and we'll be able to catch them. That is pretty much it from me. I'm going to hand over to Andy. I'm absolutely delighted that he's joining us tonight, and I would like to ask you all in giving him a very warm welcome to the stage here. Thank you. Thank you.
Pardon? Everything covered there, I think, yeah, all housekeeping. Yeah, thanks, Nina. Thanks so much for the invite for me to come and give a talk tonight at this David Elder Lecture. Welcome everyone that's come here in person and to anyone that's watching online as well. Tonight, it's not just about the lecture, it's also kind of an opportunity to launch the exhibition, which is next door. So I'd also like to take the opportunity to thank Ailsa, Steve, and some of the other guys who've helped set that up. It takes a lot of work to put an evening like this on and an exhibition like this on, so thank you to you. Thanks to Craig and the guys at the back there. Craig's worked really hard getting this IMAX looking as good as it can. We did some testing this week and it does look, I'm quite jealous. I wish I was sitting there, to be honest. I'll have to kind of, it's enormous. So I hope you enjoy the photographs. We will get into those. But before I do, you may well ask, well, how did I get involved in working on these NASA images in the first place? And really the answer to that lies in childhood. I've always had an absolute obsession with the Apollo missions. I'm not entirely sure why. I've always been fascinated with anything that could fly. I was always making paper aeroplanes, throwing boomerangs, but rockets were kind of the ultimate flying machine. And the moon, I was always drawn to the moon. I remember, we've probably got some proper astronomers in the audience tonight, but I just looked through a toy telescope when I was really young at the moon. I was just amazed at how this two-dimensional silver disk in the sky suddenly became three-dimensional. It became a world, somewhere you could potentially go and visit in a rocket, and that seemed just like the ultimate journey, ultimate adventure. And when I'd learned that actually people have done that and got out and walked around on the moon, driven cars on the moon, I was just absolutely fascinated, and I needed to know everything about it. So who were these people? What did they look like? What did the spacecraft look like? What's it like on the moon? So I've always had that kind of childhood fascination. As I've got older, it's more just a growing appreciation for how incredible this achievement was. You know, we think we're in the 50th anniversaries, Next month it's the 50th anniversary of Apollo 17, our last steps on the moon. So we walked on the moon 53 years ago, and pre-computer age, and you'll see some of the images tonight, people were flying these rudimentary looking spacecraft to the moon. It's just that kind of whole golden era, that go-getting attitude, that pioneering era of early human spaceflight is just what's held my enthusiasm to this day, really. But ever since I was very young, I was very conscious that something very important was missing, because I wanted to see Neil Armstrong on the moon. He was the first. He's this absolutely monumental turning point in human history. I want to see him on the moon, and I couldn't. And we've never been able to because he held the camera. So the photographs we see are of Buzz Aldrin, which, they took one camera. If you think about it today, it's just insane. We're going to go back to the moon with Artemis. The first woman's going to walk on the moon. Can you imagine, in this day and age, coming back saying, can we see a picture of the first woman on the moon? We took pictures of everybody else and some rocks. We didn't get a picture of her. I mean, it's just... But this is an analogue world. They had a limited number of photographs. They took one camera, one magazine, 200 photographs, and they didn't capture Neil Armstrong. Well, they caught, like, the back of his backpack, a bit of his ankle, a bit of, But I wanted something a bit better than that. So that's when I looked at the other source of film that they took on the missions, which was the 16mm DAT camera. This is like a movie camera, a bit like an old cine film camera. Very low quality. And that's when I decided to apply this quite unusual processing technique to try and create that image that I've always thought was missing from the history books. So I'll talk about that image a bit more shortly. But that really was what started me on this path of actually assessing the whole back catalogue of Apollo imagery. And there's a lot of it, and you may ask, well, why do that? And the reason is, firstly, they took 35,000 photographs, but we see the same ones over and over again. And I just thought, the content is inherently stunning. What better subject matter for a photographer than fellow humans doing extraordinary things in these extraordinary places against a backdrop that's literally otherworldly. So I figured there's got to be more in there out of these 35,000. But the main reason is almost every image we've ever seen has just been not quite the right quality. It's just been really poorly presented. And this is an example. This is a very important photograph. This is off NASA's website. So if you go to the Apollo 11 imagery, this is how we see this photograph typically. And it's an amazing photograph, and you think about this moment they've got in from the historic moonwalk. This is Armstrong, by the way, if you weren't aware. Back in the lunar module, they've taken the helmets off, and they're contemplating the enormity of what they've just achieved. And Aldrin captures this moment on film. And it is a brilliant photograph, a very important moment, but technically it's awful. The colour's wrong, we can't see any detail, and this doesn't make any sense. They use the best cameras, the best lenses, the best film, the best photo lab. We should be seeing them better than this. So I hunted down the best source footage I could for this, and I worked on it, and I worked on it, and then I produced this version. And this is how we should be seeing these photographs. Now, the colour's correct. We can see the detail in his suit, because in the NASA badge, we can see Armstrong written across his chest. We can see that expression more clearly. And if you look closely, he's actually got red, teary eyes. Now, these Apollo astronauts were top guns of the time, the best of the best, fighter pilots, hard-nosed, test pilots. They were trained to subdue emotion. So, and you'd put Armstrong at the top of that list. So it's more likely moon dust irritation or tiredness, but maybe, in this moment, he was quite overwhelmed at what they'd just achieved. So the next obvious question is, well, why aren't we seeing these images? Why is it taking 50 years to see them in this way? Why does everything we see look of relatively low quality? And the main reason is, what we've always seen has been actually based on duplicate film. So when the missions got back to Earth, that film, the film that's actually in the cameras on the moon, is incredibly delicate, it's incredibly important, it's incredibly valuable. You don't want to handle it more than once. So they didn't. They made master duplicate set. And those originals went into this frozen vault, Building 8, Johnson Space Centre in Houston, and that's where they've remained pretty much untouched for half a century. This is the vault you can see upper left. So that's to help maintain its quality. And everything we've seen since has been based on duplicate film. And at every copy, there's a degradation in quality. So we had master dupes, then there was copies of master dupes, then they make an internegative to make a photograph. So by the time in an analog world we'd seen a photograph, it was multiple generations away from the original. Now, as we moved into the digital world, it's got a bit worse because we had low quality scanning technology, having a copy of duplicate film. Someone will make a JPEG, put it on social media, guilty. Someone will copy it, put it somewhere else, make another JPEG, brighten it, crop it, and it goes on and on and on. And there's this gradual degradation in the quality, and it just hit me that the most important photographs ever taken are being seen in a progressively worse state, and they're being seen by a progressively bigger audience. And that concept drove me nuts. You know, it just shouldn't happen. When I see an image like that, one of Armstrong, it's tantamount to someone writing about the Apollo 11 mission and misquoting Armstrong's One Small Step speech. It's too important. It's too important not to be seen at the best. Now, thankfully, that original film, so this is the film that was actually in the cameras on the moon, has made it out of that frozen vault, and it's been scanned to an incredibly high resolution by NASA, not by me. I wouldn't be allowed near that freezer. They undertook the scanning, and the raw files, the raw data, are available on a server, and that's what I accessed to produce the images. And these are incredibly high resolution, high bit depth scans. So everything that was in that original film is captured in the scans. Now the film, anyone that's old enough to remember the negatives, these aren't negatives actually, it's kind of a positive. So the colour film that was in the camera, the image actually resides on that film in a positive colour correct form. So what we're seeing is effectively a digital photograph of a piece of film. And the before here is, like I say, they are very dark. This was also a very underexposed shot. This is the cover of the book. And as I was looking through these 35,000 photographs, I'm looking for anything that gives me a clue that there might be something of interest. And here it was that you can see kind of a window. I could see this, and this little purple square recognised as the Crewman Optical Alignment Site, or COAS, they called it. They like their acronyms. Basically a guidance site. So I thought, well, there might be something interesting in that one. So when I started to pull the data out, it was very apparent, wow, there's a person in that. And this took, to get to the final image on the right was actually about 2 days because it was so underexposed. When you start to push the processing hard enough, you get all kinds of artifacts. It's really frustrating. You see there's something amazing in it, but it's not worthy of being printed or being shown. But this is kind of the final result. This is Jim McDivitt on Apollo 9. And I love it. I mean, it's this atmospheric, cinematic photograph. Looks almost like he's looking up in wonder. But the reality is even better. So I researched every photograph in the book. I spoke to Rusty Swikart, who actually took this photograph. And it turns out this is a very historic moment because he's actually undertaking the docking. And it's the first ever docking of 2 crewed spacecraft with an internal transfer. So a very historic moment. Rusty told me he is concentrating unbelievably hard in this moment because the lunar module controls were set up to look out forward out the window to land on the moon, but this is Apollo 9, so they were testing in Earth orbit. So he's doing the docking, and he has to look up through the docking window, so he then has to translate all the movements through 90 degrees in his head. And the pressure was enormous. This is the first time we had humans in a spacecraft that was incapable of getting them home because there was no heat shield. They were testing the lunar module in Earth orbit. The heat shield was on the command module that they were trying to dock to. So if they didn't dock, and it had never been done before, they had no heat shield, they couldn't get home, and he's translating this through. It's an incredibly pressure moment and a very historic moment, and now we've got this wonderful portrait of it happening. So utilising the original flight film of the Hasselblads is the source of most of the images in the book. The other source is, as I mentioned earlier, this 16mm film, kind of a cine-film movie image. And what I do with that is apply quite an unusual stacking technique to that to pull more detail out. There's probably some astrophotographers in here will know exactly what I'm talking about. A lot of other people say, what is stacking? It's really hard to explain. But if we think of it in an analog world, if you imagine that cine-film footage, say it's 12 frames a second, and we've got, here's 4 frames, here's Alan Shepard on Apollo 14. If you imagine slicing that, and they're kind of semi-transparent, and you stack them on top of each other, and you perfectly align them, and then squish them, you can imagine that signal gets stronger. But the noise, because the noise is in a random place on every frame, that kind of gets averaged out. So you improve the signal to noise ratio. So the more frames you have, In fact, the improvement in signal-to-noise ratio is equivalent to the square root of the number of frames. So if we have 9 frames, 3 times improvement. So it's once you get up to 80 frames, 200 frames, it's an incredibly powerful process. We can pull out, effectively data from hundreds of frames and put them into one. So as an example, in the upper right here, that's actually a tiny proportion. This film, each frame is about the size of your little fingernail. It's tiny. This is a tiny proportion of it. So this is probably a few millimeters by a few millimeters. And then this is 80 frames stacked and processed. So, you can see there's kind of something going on there. And when you look here, you can actually see, there's some writing. This is entirely illegible, but you could almost then read that document. It's an incredibly powerful process. So I've selected 5 key images from the book, just to kind of highlight the decision-making process about what types of images are included, because they took 35,000. There's 10 hours of this 16mm footage. And I had to start with this one. So this is the images I mentioned at the start. This is what started everything. This is the image that I always felt was missing. And it's Neil Armstrong on the moon. Not long after his speech, the first thing he had to do was get a contingency sample. So he's standing still, kind of working on that. His gold visor's up because he's in the shadow of the lunar module, and the camera's locked off in the window. So because he stays still and the camera's still, it's quite easy to lift several frames, stack them, and I process them. And as I was doing it, I didn't really know what to expect, because, like I say, it's very powerful in astrophotography, and I just thought, if you can put Mars through it, why can't we put Neil Armstrong through it? But I didn't really know what to expect. So when this came out the other end, I just couldn't believe what I was looking at. I knew what this meant. There's never been an image this clear. I could see his eyelid. And I, being an enthusiast, I know what Neil Armstrong looks like, and I was amazed that that's recognisably Neil Armstrong on the moon. So it was almost like this was from the lunar module window. It's like I'd gone back to 1969, and I was in that lunar module, in that moment, editing this photograph, watching one of the most important moments in history unfold before my eyes, and I was hooked on this process then. And this is when I decided, right, I'm putting my life on hold. We've got all this raw data available, this original flight film. I'm going to go through every piece of film from every mission and see where we end up. This one, very famous image, forget Apollo. This is probably one of the most iconic photographs of the 20th century. It's not Neil Armstrong. A lot of people think it is. It's Buzz Aldrin, although you can see Armstrong in the reflection. This was kind of the best we had previously of Armstrong on the moon, really, is the reflection in the visor. I've included this because the book isn't just a piece of film that's really terrible and now it's, ooh, look at that, ta-da. There are those moments in the book, but it's the concept is it's the ultimate definitive photographic record, so it has to have all the iconic images in it as well. So it's got to include this one. But almost every time we see this image, it's had the colour zipped out of it. And I think this is the misconception of whoever's worked on it, that whenever they see any colour, oh, that shouldn't be there, that something's wrong, the spacesuits must be white and the moon must be grey, and it's desaturated. But actually the moon does have colour. And in terms of its front, you've got to consider the source of light. So light doesn't really scatter as it does on Earth. There's no particles and dust and things to bounce off it. Very, very direct. So because the sun's behind him, you can see that long shadow. He's actually illuminated almost entirely in reflected light. And you look at the source of that reflected light, you can see in his visor, he's right next to Eagle. You can see the foot of Eagle there. And Eagle, the lunar module, is wrapped in this shiny gold Kapton material. So that light actually bounces off his spacecraft and bathes him in this stunning orange gold colour. And that's not something to be edited out. That's all part of a very important part of the visual storytelling of what is an incredibly important image. So getting the colour right in the photographs is something that's been very important to do. Has anyone not seen Apollo 13, the Tom Hanks film? If you haven't, there's exits here and here. Get out. If you haven't seen it, go and see it. Or download it, whatever you do. But watch it. If you've seen it before, go and watch it again. It's an absolutely brilliant film. And if you get to the end of that film, think, what was it really like on Aquarius, on this lifeboat that got them home? What was that scrubber like? Where was it? What does Fred Hayes look like? This is what he looks like. The CO2 scrubber, which they kind of had to cobble together, that's here. This is Jack Swigert who's kind of curled up on the ascent engine cover. This is from the 16mm film, this tiny film. And now we've got it spread across 24 metres on an IMAX. And it allows us to almost step on board the spacecraft. That's something I've always wanted to do, to ride along with these space explorers on the greatest ever human expeditions. I want to look out of that window. I want to see what they saw. We see the gloriously analog instrument panels of these 1960s moon ships. So that's what this 16mm film in particular is very good at. The other reason I've included this, I mentioned earlier about the stacking process on the Armstrong image. The camera was locked off and he stayed still. But actually most of the footage I want to include in the book was filmed handheld by a non-professional photographer floating in 0G. And the person who was filming was also floating in 0G, and then a roll of tape goes floating across. You can't align and stack that in the normal way, so I had to develop a technique whereby I could continue to stack and take account of all of this movement and then bring it all together into one image. And actually, because they panned the camera, that's what's provided also the opportunity to create something like this, a panoramic shot inside these tiny capsules, so we can step on board and see what it was like. This one is, there are some images out of the 35,000, they just hit you. They just instantly convey this awe-inspiring nature of human space exploration. This is one of them. This is Apollo 16. I asked Charlie Duke about this. He confirmed he took this photograph. He's in the lunar module. This is his view. There he is, clearly orbiting the moon, and he takes a photograph of another spacecraft that's got another person in it, Ken Mattingly, his crewmate. He's also orbiting the moon, and then there is this amazing crescent Earth, 250,000 miles away, this planet from where these human visitors and these crazy spacecraft came from. So there are a lot of images like this in the book that just instantly convey that, the enormity of what they were doing in the 60s and 70s. This one is Apollo 17. I've included this just to highlight the panoramas. So they took panoramic sequences. They were trained to take a photograph, turn 20 degrees, take a photograph, turn 20 degrees. Not like a smartphone today, you just swipe you. They had to take all these individual photographs. So there are 9 in this, so I've kind of remastered these all from the flight film and then manually stitched them together. And they're great at, the rationale behind taking these was a scientific one. It was to assess where they were doing the geological sampling and that kind of thing. It wasn't so that we can drool over them 50 years later, but they're just brilliant at conveying this amazing scale of the lunar landscape. There's a tiny earthling there in a car, Jack Schmidt. You can see the tracks over to the left. This is where they've driven, and then they come up to the rim of this crater. You can just imagine the view we had from there. Right. Before we get on to the main slideshow of images, I'll just talk very briefly about the cameras. So they used Hasselblad cameras, mostly. Upper left here, that's the 500C, so that's the first Hasselblad that went into space. It was Wally Schirra on his Mercury mission about 60 years ago, 1962. He introduced the Hasselblad into space, and it was used pretty much ever since. And these were commercially available Hasselblads that had to be adapted to be used in space. Upper right, that's a Rousseau plate. If you ever wondered what all those little crosshairs on, there's more about this detail in the book. I'm not going to bore you with it, but there's a Rousseau plate used for photogrammetry, and if the film got out of, distorted in the extremes of temperature, they would know because they could cross-reference it to the Rousseau plate. It then became the HDC. Now, the HDC, the benefit of that over the 500C is it had an electric motor. And that meant when you press the shutter, it would wind itself and you could take another photograph. The technology was absolutely astounding, but that was it. That was the only automated feature. There was no viewfinder. They had to set the focus and the aperture themselves. There was no viewfinder because you used to, some of you I've noticed when you're coming in are probably old enough to remember, if you don't mind me saying, oh my God, the cameras whereby there was a focus HUD that came up, and that's how you'd compose the shot. You'd look down it and you could see through the lens, but you can't do that in a spacesuit and a helmet. So all of that went. This is a replica, unfortunately. And then when they went onto the moon, they used this kind of trigger assembly to release the trigger, and that hooked onto the RCU, the chest pack, and that was actually Neil Armstrong's idea, to keep the hands free and still be able to just go and pull the trigger and take photographs. And he described the astronaut effectively as a bipod, 2 legs, camera attached to him, and that's literally what they did. They would point like that to compose the shot. But what's incredible is, without a viewfinder, they trained so hard, 99% are right on the money. You know, the composition, I didn't have to do much cropping or rotating or what have you. So they became very skilled at taking the photographs. Very briefly about the book. We're going to see about 40 images here. There are about 40 in the exhibition, some are in both, but there's 400 in the book. And like I say, it's the opportunity to see the moon landings that we've never really been able to see before, thanks to this new flight film. Worked hard at getting an authentic record. It's very important to do that, so I've been lucky enough to have some of the Apollo astronauts involved and to critique what I've done and to give me, you know, what do I need to represent. You can push digital processing too hard because it's so powerful, but actually I wasn't pushing it hard enough, because the visual in space is incredibly stark. You have this incredibly black, incredibly whites, no atmospheric haze, so everything is as sharp at your fingertips as the far horizon, so you do get a very stark look to them. We've worked hard on getting the print right, so every photograph has got a coat of varnish over it to really improve that contrast and boost those black levels. So, if you're watching online, we're going to dim the lights here, just so everyone can feel like they're in space. So you'll go to a full screen if you're watching online. I've got quite a lot of images to get through. I might talk quite quickly, but let's see how we go. So the book starts with pre-Apollo. So these are the missions, Mercury and Gemini, that paved the way to go to the moon. And this one is Gemini 4. This is Ed White, the first American to perform a spacewalk. This is the first portrait taken in space. It's the first time we can see an American flag in space. If you look in the reflection, you can actually see the Gemini spacecraft there. And this was actually a turning point in NASA's appreciation for space photography, because there was a bit of the public affairs imagery really wasn't very high up on the agenda, basically. You know, the pilots were very busy. They didn't want to be taking fancy photographs, but when these photographs started to come back and seeing a human form against Earth and the public reaction to them, that's when NASA realised, wow, this gets people excited. This ensures we can get continued congressional support and funding. So this is where things changed after these photographs, seeing a human form against the backdrop of Earth. This is Gemini 5. So you'll notice the pre-Apollo photographs, because they're in Earth orbit, they do look very different. Obviously, they're Earth-based. And there's just some images that are almost like a piece of art, I think. You know, and this is our Earth. This is the salt flats in Iran. This was taken by Gene Cernan, last man on the moon, but this is his Gemini mission, Gemini 9A. And he's standing in the hatch, so this is kind of an EVA, but they call it a stand-up EVA, and this is his view. But just look at how rudimentary that spacecraft is. You know, the way these panels are kind of riveted together, how bright white that sunlight is. It must have been pretty spectacular to stand there. Apollo missions. So the first crewed mission, or manned mission, we'll call it crewed missions, was Apollo 7. This was only in Earth orbit. We didn't have a lunar module. They were just testing the command and service module. So normally there would have been a lunar module on future missions here at the top of this is the Saturn 1B, but it would be the Saturn 5 typically. And there would be a lunar module there. They would turn round, go and dock and extract the lunar module, and off they went to the moon. You'll notice these SLA panels, one of them didn't fully open. That would have caused a problem. And on future missions, actually, they fully, we'll see a bit later, they fully expanded these separated completely. This is the commander, Wally Schirra. I mentioned the first Hasselblad in space. He took it. He's the only man to fly Mercury, Gemini, and Apollo. You can see he's been there a while. His, stubble's growing, and if you look here, that's kind of some good old like duct tape and some old food packaging. That was to protect the neck on splashdown, because they were very ill at this stage of the mission, and they didn't want to come down with the helmets on because they wouldn't be able to clear the sinuses, clear their ears. Sorry. So they point blank refused to wear the helmets, so they kind of taped some food packaging to help protect the neck on splashdown, different times. Apollo 8, so this is the first time, just think about this, the first time humans completely escaped Earth. So we'd been into Earth orbit, 17,500 miles an hour, you accelerate to 25,000 miles an hour and you escape Earth completely. And that gave this opportunity. This is the first ever photograph of the whole Earth taken by one of us. And you can see, this is kind of Central America, this bit here is Florida, so the launch site's just there. They were also the first to see and photograph the far side of the moon. Bill Anders said it looked like a sandpit that his kids had played in all afternoon because it was completely beaten up. You can kind of see that in this photograph. Very different to the near side. The far side is a lot more beat up, as he said. Some scale, these mountains here are about 5 miles high. These are the 16mm films, so these are the kind of images that allow us to see what was going on board. These are the first 3 men that escaped Earth and went and voyaged to the moon. Upper right, a key one, this is Anders, and he used this camera and this lens through this very window to take one of the most famous ever photographs, which is Earthrise. A very, very important image, an image that was kind of a catalyst for the environmental movement that continues today. Apollo 9, back in Earth orbit. This time we've got a lunar module and a command module, and the testing, separating those, and the docking, as we mentioned earlier, that Jim McDivitt undertook. This is Dave Scott. He's popping out of the hatch here, and he's taking our photo. He's taking a photograph of whoever's taking his photograph, which is Rusty Schweikart. And now he appears to be taking our photograph. You might notice something a bit different about that camera. It's got a winder. So as well as performing this first time they've ever tested the PLS of the backpack. This is the next time this a backpack was used was by Neil Armstrong. It was very important simply to test that. He was testing he's out on an EVA. He felt very sick actually, and they had to keep it quite a short EVA. And with everything else they've got to do, they need to take photographs. And when they've taken a photograph, they need to wind the film. So, as I said, later on they use the EL. Also, the convex shape of the visors means we can see the whole Earth. And there's Dave Scott popping out of the command module taking his photograph. This is Rusty Schweikart again. This was taken by Jim McDivitt from inside the lunar module through the window. And at this moment, he had a bit of an epiphany. I asked him about this, and he just said he had 4 minutes of peace, basically, because of a jammed magazine. So they said, right, you sort your magazine out, Dave. Rusty, you got 4 minutes. So we had complete silence. He said, I can't express to you the depth of silence. There was nothing coming through his radio. There's no concept of speed, because, of course, there's no wind resistance. But he's travelling at 17,500 miles an hour out there. He released his right arm to face Earth to get that view. And because he was motionless, he was floating kind of within his suit, so he felt almost naked, complete silence, and he said the view, the contrast of this incredible black, and that colourful Earth, it'd send anyone doolally, I think. But he had this epiphany of, God, what is going on here? How did I get here? How did we humans get here? Where we're just looking down at our home planet. Apollo 10 went to the moon but didn't land. They got to within 7.8 miles of the surface. And this is a little game to spot the lunar module. This is taken from orbit from the command module, and I've lost it. No, there it is. That dot is the lunar module. Nothing happened on this one. We'll skip through this one. No, so this is Armstrong nearest the camera, and Aldrin in the command module on the way to the moon. This is in lunar orbit, so they'd separated and they're about to descend to the surface. And Michael Collins said, that's a fine-looking machine you've got there, except you're upside down. And Armstrong instantly said, well, somebody's upside down, because who's to say what's upside down in space? It's a nice upside-down portrait of Eagle. We've seen this one, Armstrong, upper right. This is the exact moment he puts his left foot and says, that's one small step. This is Buzz Aldrin. Upper left, so when I went through the 60mm film, at its normal speed between scenes, you can't really see anything. There's a bit of a flicker. There's a particular bit of a flicker between these two scenes, so I always made sure I went through it frame by frame. And what happened here is Aldrin was mounting the camera to the window, about to film the descent. And he obviously accidentally just flicked. He was shaking the camera and it just flicked on a few frames. And there was something white. I thought, well, that looked a bit like a spacesuit. So I turned them upside down, stacked a couple, and made a little panorama. And it's Neil Armstrong. And it's not a particularly stunning image, but it's very rare to see anyone flying a lunar module on any mission. And it's Armstrong at the helm, about to take Eagle down to the first ever landing on the moon. So it's quite an important image, even though it's not as stunning as some of the other images. And there they are. There's Eagle, Tranquility Base. Aldrin about to get the experiments package out. That's a panorama of two photographs. This is a panorama of multiple photographs. This was taken by Neil Armstrong. This is the furthest that either of them ventured from the lunar module on Apollo 11. It's about 60 metres. He came over. This is Little West Crater that they had to fly over, and he wanted to do some rock samples around the rim. And he took this panoramic sequence. Now, we'll see a bit later, they got a lot further than 60 metres on future missions. And this was the view. This was one of the last photographs. Coming home, Earth must have been quite a relief. Apollo 12 struck by lightning on the way up twice, but they made it to Earth orbit. And I mentioned earlier those SLA panels in future missions, they got kind of fully expended. You can see one there. And there's one there as well. And so this is after translunar injection. So this is where they fire the engine to get up to 25,000 miles an hour so that they're on the way to the moon. And this is arrival at the moon. Lunar orbit. Lunar module Intrepid about to make its descent. This is quite a good one. From orbit, the moon varies in colour from just grey to a very definite tan colour. And you can kind of see that in this image. Like I say, the moon isn't entirely grey. The other extreme from that wide angle, here's a super close-up. So this is Pete Conrad's boot print. And they took a stereoscopic camera. Alan Bean took this. This is about 70 millimetres by 80 millimetres. And what's interesting is it almost looks like it's so crisp, it's like it's been made in snow, and yet it's dust. And the reason for that is the particles, because there's no wind or rain and erosion, all the particles are very irregular shape. And so they lock together really well. There's a kind of a slight electrostatic charge to them. There's 1/6 gravity, so the boot print doesn't slump. So we get these really crisp boot prints that will remain there for millions of years. Apollo 13, this is the far side, so they're about to slingshot around the moon to try and get them home alive. Hayes and Swigert hadn't been to the moon before. Lovell had. So Swigert and Hayes are at the windows like tourists taking these photographs, and Jim Lovell, you can hear it in the transcripts and in the voice tape recordings, he gets quite annoyed with them because he says, look, we've got this really important burn to make, and if we don't make it, you're not even going to get your film developed. So get the cameras packed away and focus. But it must be incredibly tempting to have that view and not take photographs. This is quite a poignant one. This is inside the lunar module. They had to shut down most of the systems to conserve every milliamp. So it was very dark. This is the lunar contact. When you hear them say contact light, this is the contact light that says they've landed on the moon. Of course, that never illuminated. On Apollo 13, they didn't land. How rudimentary. Look, they used sticky tape and hand-wrote instructions on because they were flying the lunar module in a very different way. It wasn't to land on the moon. They had to use that engine to get them home to propel them on the command module that was attached. So they're almost flying it backwards in a way they'd never fully trained to do. And this was literally just a visual reminder, left, right, fore, aft. You know, it was a visual reminder. It was so rudimentary, but they got home. Apollo 14, this is lunar module Antares, and I've included this. I think it's quite an atmospheric one. You kind of feel the lighting conditions. You can see how low the sun is, and that was, you know, most of the missions did land near the terminator, so between the shadow and the light, in order to have the relief that's provided by these long shadows because of the low sun angle. We're in the home of golf. We must have golfers. in the audience. Popular pub question, how many golf balls are on the moon? 2. How far did it go? Miles and miles and miles is what Alan Shepard said. We always knew that one was there, his first one that he shanked. That's not a bunker, that's not a rake for the bunker, that's the solar wind experiment that Edgar Mitchell threw like a javelin and was very pleased that it went further than Shepard's first golf ball. The second one, he said it hit miles and miles, but we'd never been able to find it. And now when I was going through these high resolution scans, I was determined to find it. And what looked like a rock before, I could zoom in and he's definitely, it looks a bit like a rock there, but it's definitely a golf ball. It's his second golf ball. I studied the shots from the film so I could work out, I can't quite find it now, I found his divot. Anyway, so I was able to measure exactly from divot to ball, and it was 40 yards. But if one of these astronauts, any golfer likes to exaggerate, you know, if one of these astronauts, these very competitive types, didn't exaggerate even more, I would have been disappointed. But yeah, still did, I mean, one-handed in the biggest bunker in the solar system, no preferred lies. I think he did incredibly well, to be honest. This is just before the left lunar orbit. Nothing to say about this really, other than look at it. It's I was just amazed at this point here where the limb kind of terminates. Is exactly on the lunar horizon. This is one of the few images that I did crop heavily. The photographs just didn't work unless it was cropped. So some of them I did crop, guilty. But in the book, it tells you if it's been cropped or if it's been rotated or... Right, this is 60mm film, so this is on the way back from the moon. This is the mission timer that was started at launch, and 190 hours, 33 minutes, 35 seconds is almost exactly halfway back from the moon to the Earth. And this is what was going on board. Edgar Mitchell isn't actually shaving, he's pretending to shave, because when he landed on the moon, he said, I'm not going to shave from now. And he didn't for 2 years. He sported a beard for 2 years. So he's pretending to shave in that photograph. In that film, sorry. Apollo 15, the most incredibly picturesque landing site. This is from orbit. We can see this horseshoe-shaped mountains. This is the Hadley-Pennine region. They landed almost exactly there. And there's this valley and this volcanic rill kind of meanders through it. It's just stunning. Actually, when this photograph was taken, Scott and Irwin are actually out on an EVA and they're about to find the Genesis rock, a very important rock, having cross-referenced the times. And you can almost pick out the shadow of the lunar module actually in this photograph. There's such resolution. And this is what it looked like on the surface. So here's the rill. Again, some perspective, you can fit the Empire State Building in there. These rocks are the size of houses. The Swan Range is about 10 miles away. You can't quite see in here. On the full resolution image, you can see the lunar module. It's kind of over there. And listening to tapes of this particular moment is brilliant because they've been sampling this boulder. They've made it up this incline, and they kind of don't realise they've made this that much of an incline, and they're busy in a way. And then Dave Scott turns round, and he has that view, and you can hear him in the tape just saying, Jim, turn round. Look where we are. And they try to explain this. He said it's the most incredible thing I've ever seen. I mean, what a view. There's a lunar module Falcon. It landed really hard. You can see it landed part in a crater and at an angle. It's 11-degree angle. 12 degrees was considered the safe takeoff angle, so quite fortunate. Actually, on the next mission, John Young had an interesting way of making sure it didn't land quite so hard. Again, this is different times. It's not like SpaceX, automated landing like a pencil. John Young went, right, when I see the contact light, I'm going to count out 1 potato and then hit the stop button. And that's how they did it. Apollo 16, this is Charlie Duke. This Plum Crater, I love this one because you can the part of the rover here and you can follow his footsteps all the way around the edge there to where he is. This was a panoramic sequence in the book. This is a 3-page gatefold that you fold out, and then when you turn it on the next side, John Young actually continues this panorama over this direction, and John Young moves into shot again. And the contrast's really interesting because you've got these really deep, battered up, cratered surface, And when you look this way, it's just this vast plain. That's quite a contrast. One of the few human moments during Apollo, Charlie Duke took a family portrait that he took in his backyard for this purpose, left it on the surface and took this photograph. And it's just interesting to see that life, that colour, against this desolate, nothing, dead. So quite a poignant moment. That sadly will have very quickly curled up, will have quite rapidly faded as well. So I contacted Charlie and said I was going to send, I've got a little bit of space on the astrobotic mission that's going to land on the moon at the start of next year. I said I'm going to send a tiny exact copy of that photograph back to the moon, and it'll be in a capsule so it'll last a lot longer. There's someone else in the audience I know whose photograph's going as well. I won't ask you to put your hand up if you're embarrassed, but you're going along with Charlie Duke to the moon. And, you know, people say the moon's just a boring, desolate place, but I think that's quite stunning to me. That's the far side of the moon. This is after trans-Earth injection on the way home. This was taken by the metric mapping camera, a different camera, huge resolution, 127mm film, an enormous amount of detail in these. You can zoom in to, you know, the most minute area in the full resolution image. And here we are, Apollo 17. So it's the 50th anniversary in 2 weeks. And they took, well, I'm just going to be a bit quiet on this and let you just drink this in, because this is the most reproduced photograph ever taken. The whole Earth. And what I try to do in the book is put images like this in some context. So we see this, and we have seen it everywhere. Adverts, cereal packets, T-shirts, textbooks. But when you see it in isolation, it's like, oh, wow, yeah, that's a really nice photograph. Look, it's the whole Earth. Move on. But when you just think about, you look at the photographs that were taken just before, the photographs that were taken just after, you listen to what the astronauts were saying as they were witnessing this, and you just think about the fact there was someone, 3 men in a tiny capsule, speeding at 20,000 miles an hour away from their home planet on a trajectory that wouldn't naturally just get them home, and they lifted the camera to the window and took that photograph, the whole illuminated Earth amongst the blackness of space. I think that's when images like this just resonate that much more. Jack Schmitt, the only scientist to visit the moon, and this is probably the clearest photograph of an astronaut's face on the moon. I'd worked quite hard to get a lot of the glare off his visor. You can see his gold visor is up. He was guilty of doing this a lot. He kept getting told off because it can damage their eyes. It's incredibly bright. They describe the moon in sunlight as like a snowfield on a summer's day. It's incredibly bright. So but as a geologist, I think that's the reason. He just wanted to see it without that kind of golden tint. Another cracking panorama. Gene Cernan kind of climbed up onto this little inclination here to get this view. Again, here's Jack Schmitt. And the lunar module is that dot there. And that's just under 2 miles away. So as I mentioned earlier, on Apollo 11, they ventured 60 metres. Here they are 2 miles away. They actually got to 4.7 miles away from the relative safety of the lunar module. That was the limit, the walk-back limit. They reckon they could just about get back walking if they had a problem with the lunar rover. Most people would say, doubt it. But they just went for it. You know, they were pushing the boundaries. You couldn't do this today. You know, when we go back to the moon, you think like Apollo 8, for example, internally NASA gave the crew a 50-50 chance of coming home. Now, Bill Anders thought his chances were more like 1 in 3. But there was no hesitation. If it was 1 in 10, there would have been a queue to go and be the first to go to the moon. They had to beat the Russians. They had to go be the first to visit the moon. So they took risks that you just couldn't take today. And including this, you know, they're not going to be going 4.7 miles away on a vehicle that might break down. Thankfully, it didn't. I mean, it was an incredible workhorse. This one I love. This is the last man on the moon. This is after the last EVA. This is the last time we had humans on the moon. They're back in the lunar module. It's a panorama of 2 photographs. So here's all the filthy suits and helmets just stacked up on the ascent engine cover. And you'll see there's a bit of camera shake on this, which you might say, oh, that's a bit frustrating, but it makes it for me because it's clear this is a human took this photograph with a bit of human error of a fellow human. He's filthy, you can see his biomed sensors, and he's in this tiny capsule on the lunar surface. As I said, the rover, a brilliant workhorse. This is a great portrait of it in its operating environment, and I've included this one because it's just a reminder that what we're looking at is effectively a digital photograph of a piece of film. So these are kind of the sprocket holes that advance the film. It was a positive colour image that resides on that film that was in the cameras on the moon that have now been digitally scanned. The final one, this is before I'd worked on it. This is the raw image. This is the last lunar module coming back from the last mission to the moon. And when I looked here, I thought that looks, there might be something in that. So if we basically switch the lights on by processing it, we can see that's Gene Cernan in his bubble helmet, the commander, the last man on the moon, piloting his ship back from the lunar surface in 1972. And on that note, that is the end of, well, this part of the presentation. So thank you for listening. I'll leave that one on. It's a nice picture. Where's Nia? Oh, here she is.
Than here than there are in the planetarium, so getting my steps in at least. Thank you, Andy. That was absolutely incredible, and I think we definitely made the right choice when we went with the full IMAX.
Yeah.
Hearing people's reactions to some of those images was an absolute joy. I can't even tell you. So we do have some times for questions for people watching at home. Remember, if you just pop question in capitals, we'll be able to catch it a bit more easily. I will be your voice, but we've also got some roving mics around, so if you do have a question, pop your hand up and we'll try and get one to you as quickly as possible. There's one up the back here. While the microphone's going to the back, we do actually have one from YouTube, and it was, and I suppose it's probably maybe quite a tricky question, of all of those images, which is your favourite?
It's like picking your favourite child. It's really hard. Like I say, they took 35,000. I like it, different ones for different reasons. So there are those that, like I say, just instantly hit you, this awe-inspiring nature of human space exploration. Just inherent. There are a lot of them are just inherently stunning images. The panoramas, like I say, are great at being able to almost go and set foot on the moon yourself and appreciate the landscape. The historical ones, so I don't think anything will ever match again, anything I ever do, enhancing that image of Armstrong, the historical significance of that and that moment. But it's probably the cover. I know it's probably obvious because it's on the cover, but that image has got a bit of everything. It was in a really bad state before, so it almost never gets seen. It's an astronaut that perhaps a lot of people don't actually know. Sadly, he passed away very recently. It's an astronaut that perhaps a lot of people don't know that well. Like I say, it turned out to be this atmospheric, cinematic shot. The lighting's amazing, and the way he's looking up, and the fact that actually it's a really historic moment, and the pressure, and thinking about what he's doing in that moment, that one has probably got a bit of everything. Yeah.
I think that's totally fair. We'll take the question from the back.
As this lecture is about photographs, did NASA pioneer the selfie?
Did they pioneer it, or did the astronauts? They did take some selfies, actually, surprisingly. I mean, I just wish Armstrong did when he was on the lunar surface, but it's just not him. The first selfie in space is a bit of a contest between Michael Collins, two Apollo 11 astronauts, funnily enough, but in their Gemini days, Michael Collins and Buzz Aldrin. So the first strictly was Michael Collins. He took it on his Gemini that was before Aldrin's, but it was inside the spacecraft. So he was in space. So you could say it's the first selfie in space, but Buzz Aldrin would disagree. because he took his out on an EVA. So he said, well, no, I was out in space and I took a selfie. Collins did do that quite a lot, and I'm so glad he did, because there are a few astronauts where there's almost no imagery of them in the missions. And on Apollo 11, a vital member of that crew, there's one photograph of him. And it's massively it's in the book, it's massively underexposed, but and Aldrin took that. So the first 2 photographs on Apollo 11, Aldrin was in the middle seat. He turned left to take a picture of his commander, Neil Armstrong, turned right to take a photograph of Collins, and that's the only photograph of Michael Collins during Apollo 11. Sadly.
Come through from back here. It was really wonderful to hear you talk about your technique for stacking up the photographs. And I guess, spoilers for any of your future projects you might not be ready to share yet, but is there anything else historically that you think you could provide us a more detailed look at with the technique?
You could apply it to, particularly old film. That 16mm film is very noisy. Noisy as in, it can come from the actual medium of the film, it can come from the digital processing. There's 2 elements to an image: the signal, which is what we want, and the noise that gets in the way. So any old film that's particularly noisy would really suit that technique. It could be applied to anything, but I've just not got enough time. But the next thing I'm working on is Project Gemini, so that's the missions that were before Apollo, and I'll do exactly the same thing, go through every frame of 16mm film, stack it, take that original flight film, and the photographs from Gemini are very different, and they're absolutely stunning. Very different to Apollo, because Apollo is predominantly moon, Gemini is predominantly Earth, so it's more colourful. They had a slightly different camera, particularly on the latter missions. It was a Hasselblad super wide camera, and it was better at capturing the inside of the spacecraft, and when they were out on the EVAs, and a bigger proportion of Earth, and they're just absolutely stunning. You see the Gemini missions referenced in a lot of blockbuster Hollywood sci-fi movies. There's a particular look that's clearly referenced. They're stunning, so I can't wait to actually start on that. Yeah.
And you'll come back and pop them on the IMAX.
We'll have yeah, I'd love to. Yeah.
You referenced with the footprints how sharp moon dust was, and I've read a lot that they had a lot of problems with their suits with the dust and the static. Did they have any, considering they only took 1 camera, was that considered to seal the cameras at all, or to clean the lens? Did they have a method for cleaning the lenses?
They did on the latter missions. Again, different times. It was just a brush. But they used the brush. Moon dust is actually a massive issue. I mean, Cernan talks about it when I was listening to the tapes a lot, about actually when we go back to the moon, we've got to sort this out, because it's not great to breathe in, because of, like say, the irregular nature of it. It could be almost like an asbestos type effect. We don't know. So when we go back to the moon, we're staying for longer durations. Breathing that in is a potential problem. It gets everywhere. And it's so hard to get off, because it's that electrostatic charge. It's irregular. It almost stuck to the suits. Camera-wise, they were kind of sealed, but they weren't in a vacuum. So, and it was unnecessary any, because the magazines that they had to constantly change is kind of, that bit's the magazine. So when they were changing the magazines, sometimes moon dust did get in onto that Rousseau plate, with the little crosshairs. And then they put the magazine back on, particularly on Apollo 16. I had a terrible time. I'd spot heal, so zoom right in and take a lot of these out. I didn't take them all out because, again, it's an important part of the visual record, but if it ruined part of the image, I'd take some of them out. And when the film advanced, it would kind of rub on that, and you get streaks of it. So it did get into the cameras. On the lens, it wasn't too bad an issue unless they were taking it kind of into the sun, and there was a bit of a glare from the sun, and you could see the dust on those. But you can do contrast adjustments digitally that can take that out. But yeah, moon dust, when we go back to the moon, it is something they need to kind of get to grips with. Better hoovers.
On the Apollo 12 mission, there seems to be a lot of photographs were in black and white. What was the reason for that rather than the colour?
There was on 12 and on 15, and that's at the insistence of the engineers, really, and the scientists, the geologists. A lot of them didn't want colour because colour is, although they use reversal film, so this is a film whereby it's processed in the same way when it gets back, and like I mentioned earlier, it's a full colour image on the film itself. Now, they didn't use negative colour film because if you do that, someone in a photo lab has got to make a decision on how they process it, and there could be a variation in colour. The scientists don't like that, as you would imagine. Black and white it's black and it's white. It's also higher resolution. So the black and white film had about 170 lines per millimetre, and the colour about 80. So it's much higher resolution. So the engineers and the geologists actually preferred black and white. Yeah. And the colour, actually Apollo 11, so Apollo 12 was the first opportunity to use black and white because Apollo 11 only took a colour magazine, but they weren't going to. It was going to be a black and white magazine. And again, I mentioned this kind of to and fro from, it was kind of deep slating in the astronaut office, this original 7 Mercury astronaut, hard-nosed pilot, we're not taking fancy photographs. And the engineers versus a guy called Duff, who was the head of public affairs, and he said, they were going to take one black and white magazine. He said, if you're going to have a photograph of the first man on the moon on the cover of Life magazine in black and white, and they said, okay, and they got the way. As it transpires, there was no photograph of the film, so colour or otherwise. But that's the reason for the black and white. So they took a bit of a mix on different missions. Yeah, I can hear you, if you want to shout.
What did the astronauts say when they saw these pictures?
Well, what was particularly nice is, especially with Jim McDivitt, I'd spoken to him a bit, researching the book, but he was 90, at the time he was 92. Some of the astronauts, could get, some have aged better than others in terms of the mind, of course. Rusty Schweikart's incredibly switched on. Jim wasn't so much, and his health was deteriorating, but we rushed a copy of the book to him only a few weeks before he passed, so he did see it, and apparently he loved it. He loved being on the colour. I thought he looked very handsome. So that was worth more to me than anything. Getting that kind of feedback. Charlie Duke have enhanced some images that like a coin, a medallion. He left, and he's had a piece of beta cloth. He wrote C64, which was his class at Test Pilot School. He said, I don't remember leaving that. But generally, yeah, and NASA as well like what I'm doing because it's not sponsored by NASA. But they like even amateurs to go and have a go at this footage, and it's celebrating their history. It's getting people excited about the future and Artemis. So the feedback's just been amazing. But hearing that from Jim McDivitt particularly was very special. Yeah.
I think we've got time for one more question.
We'll pass that on along.
No pressure with it being the last one or anything like that.
Did we go to the moon? Go on.
So with like 35,000 images, how did you know that you'd finished? So you've got all these, you've put it all together. You could go on forever and ever. How did you know? Was there a point that you just thought, this is it, I've done it?
Well, I starting a project like this, I realised I can't half do it. So I can't get through to the end and think, what have I missed something? So I had to look at every single one. After about 5,000, I regretted it a little bit. But there was always, it's probably hundreds before you come up with like a Jim McDivitt or an Armstrong or something really interesting. But that just kept me going. I've always been fascinated with this, to come up with image of kind of a historical significance. Like I said, that moment when I worked on that Armstrong image, that kept me going. And then the Jim McDivitt, there was always something that came along that I thought, well, what's next? What's in that next batch of 2,000 or 3,000? And I was keen that this was like a complete record. It had to cover every piece of film that was taken during the Apollo missions, or else there's no point. What if I missed something? So I knew when I got to the end when I'd done number 35,000. But selecting them was it's a near impossible task, really. But I selected images that also help tell the story. So I've researched each one to pinpoint exactly when the photographs were taken, who took it, what are we looking at, images that help tell the story. So reading the captions whilst looking at the images gives us the opportunity to follow each mission and follow the progression of the whole programme, from seeing the first curvature of Earth to our first steps on the moon to our last steps on the moon on Apollo 17. So there was all kinds of different factors that determine what it makes it and what doesn't. And that was a bit of a killer, but hopefully I made the right choices.
They are absolutely remarkable, and as we did say, we do have a sort of choice selection highlights on display on floor 1. We have run out of time for questions, but there is still time to take in some of the images. The science mall will be opening shortly, so just give us a wee moment to get people in place, and we'll be able to do that. I think someone's turned my microphone off
me.
there.
Sorry.
No.
Pitching me.
We'll be able to get that in place for you, so do take your time to explore that. The planetarium is also open. We've got a selection of images kind of scrolling through, so you can just sit quietly, enjoying the audio from Apollo 17, enjoying some of those images in your own time. And for those of you who've pre-ordered a book or who've picked one up on the night, we will be doing a book signing in the Space Zone as well. So we're delighted to see you over there. But with all of that, I'm kind of a little bit overwhelmed at some of those, I'll be totally honest. They're absolutely incredible. Just want to say a massive thank you to Andy for coming all the way to Glasgow, for sharing Apollo Remastered with us. I'd like to ask you all joining me to say a massive thank you. Thank you.
Thanks, David. Thank you.